Just a minute. Over. Lift adjustment. Angle is not coming correctly. Okay. Hot to open the window. Just a minute. Open the window and come. Where I placed it. So fast escape. Is the voice clear? Audible fully? No problem? Voice okay? Okay, I will start now. See, first few minutes, little time, I will not go for any chats, but I look for any problems. Otherwise, because repetition, see, just to get good control, you first write the question. See, I'll tell you, yesterday we last class question, a simply support beam of span L loaded by a central load W, they want to find maximum slope and maximum deflection. That is theta A is the, I'll do it here. See, this is a question. Find maximum slope and maximum deflection. If you remember, maximum slope we got, I'll write here, WL square by 16 EI. YC, maximum deflection, we got WL cube by 48 EI. Then, in the same question, see, this is the most important. What? Maximum slope and maximum deflection. But then I have given 2 extra points for you. Anywhere can be given. Here, don't see there. I see this question. Don't see that question. This question I am telling. That is something else. That is something else. Don't see that one. Do not see this one. Then I asked to find slope and deflection at P1 and P2. See, at P1 and P2, you have to find slope and deflection. Extra points. If you remember, slope at P1 came, I will calculate once again, not a big issue. 13 Allah minus 1 by 16 plus 0.5 into bracket 1 by 3 close square divided by 2. 5 by 144, 5 by 144 WL square by EI. And deflection at P1 came, sign all, see the direction clockwise, anti-clockwise, all you get it here. I won't bother about those things. Deflection came 1 by 16 into 0.5 minus 0.5 into 1 by 3 close cube divided by 6. 73 by, calculate wrong, minus 1 by 16 into not 0.5, how much it is? Bracket 1 by 3 plus 0.5 into bracket 1 by 3 close cube divided by 6. 23 by 1296 WL cube by EI. And at the other point P2, slope came 1 by 16 into minus 1 plus 0.5 into 0.2 square divided by 2. That's all. 21 by 400 WL square by EI. Even if you cannot see, no problem. Even if you cannot see, no problem. Okay, can't idea? Okay, I'll slightly tilt the camera. Slightly, I'll tilt the camera so that because that little side is not visible, I think. Okay, now visible? Now visible? Visible now? What I wrote just now? What I wrote just now? Visible now? Actually, you know the answer last time. No, what I wrote just now it is visible. WL cube you need not see. Number is more important. That numbers. 23, 5 by 144, 23 by 1296. Not visible. Ayyo. Why not visible? I can see here. Not visible. 5 by 144, 23 by this camera. 1 minute. I'll slightly reduce the camera. Okay. Okay, now okay. Now everything will be visible. Okay. Now fully visible, tell me. Right side, now fully visible. Now, full visible now. Here actually if I want to see comment, I should go other side. Okay, then lastly, deflection at P2 also you got. See, how to calculate, I told you last time. It is minus 1 by 16 into 0.2 plus 0.5 into 0.2 cube divided by 6. Never worry how I am getting it. 71 by 6000 WL cube by EI. Tell me, yes or no? This was the result we got last time. I will tell you why I am telling it. This was the result we got last time, correct? Yes or no? This is the result we got yesterday for that question. Okay, now take today's question. See, I write here. Present class question. Today, that is today, present class question. Numerical. A simply supported beam is of span 12 meter. 12 meter. It is loaded by a central concentrated load of 80 kilonewton. Central load at 6 meter. A and B. Okay. A and B. Over. Now, EI all I am not wasting time now. Some other time, after 1 or 2 questions, I will take EI value because that you already know it. How to substitute EI? Waste of time here. No. Question is, see, find theta max, maximum slope and maximum deflection. Okay. Then also find slope and deflection at one point is P1, other point is P2. P1 is at 4 meter from left end. From left end. P2 is at 2.4 meter from right end. Right end. So I written here, see, present question is span 12 meter. See, load 80 kN, span 12 meter. One point P1 is 4 meter from here. This is 2.4. Now tell me, what is 4 by 12? What is 4 by 12? If I take this question, see, if I compare this question with our last class question, can you compare? If you compare these two, for present question, your W will become 80 kilonewton. Your span is how much? 12 meter. Now, over. The P1 is at how much? 4 meter from left hand. See, span 12 meter. 4 by 12. How much answer? What is 4 by 12? In ABC format, not decimal. L by 3. Okay. That is, that 4 meter is actually what? Is at 1/3 of L. Correct. And P2 is at what distance? 2.4 by 12. Tell the answer. 2.4 by 12. See the position of this point with respect to span. What part of the span it is? 2.4 by 12. 2.4 by 12. 1 by 5. L by 5. 1 by 5 of L. Or you can tell this question, today's question is set so that it is exactly last time question. Point also same. Only thing is, last time book work, WL, this time numerical. Therefore, if I substitute W equal to 80 kilonewton, L equal 12 meter, tell me for today's class question, what theta A should come? What theta A should come? Theta A, theta B. Slope, maximum slope. Tell the answer. 80 into what? 80 into 12 square by 16. Tell the answer. 80 into 12 square by 16. Fast, fast. What we are writing? What answer should come today? What answer should come today? 720 by EI. We hope it will come. What is this? What is Y at deflection? These are the theta max and Y max. What Y maximum? 80 into 12 cube divided by 48. Tell the answer. 80 into 12 cube divided by 48. Because why? Same book work. 2880. 2880 by EI. And at that point P1, tell what theta should come, what Y should come. Tell the answer. 80 into 12 square. 80 into 12 square into 5 by 144. Answer. 80 into 12 square into 5 by 144. Answer. Into 5 by 144. Fast answer. 400. 400 by EI. Deflection. 80 into 12 cube into 23 by 1296. This is only for checking purpose. 23 by 1296 into 80 into 12 cube. Because by same point, 2453.333 by EI. And also the point P2, I'll put here now. This is one. And for the point P2, what theta should come? 21 by 400 into 80 into 12 square. 604.8. Okay, thank you. 604.8. What deflection should come? 71 by 6000 into 80 into 12 cube. 71 by 6000 into 80 into 12 cube. You are not supposed to do this way because why? Who is telling you this formula? See, these you can apply, standard formula. These are random points. Today I am telling you only for checking purpose. 1635.84. Okay. 1635.84. Hope by EI I am not writing. Now we hope that that answer will come. Okay, start. Solution. Fast time solved because last time fully solved. So today I will not write too much of statement. I will dictate in the class. You see last time question and make fair copy. Clear? You see last time question and make fair copy. Statement all see last time question. Clear or not? Those who are serious. Last time question you should see and make fair copy. Okay, start. 80. Symmetry is there. Your reaction VA, VB equal to half of 80, 40, 40 kilonewton. Bending moment diagram. 0, 0. Bending moment here. 40 into 6 is 240. This length is 6 meter. Elastic curve. Theta A, theta B, tangent at A, tangent at B, theta C 0. This is the tangent at center. See, tangent at center. Start one by one. First, I want theta maximum. Is either theta A or theta B, but both are same due to symmetry. So find theta A. Use first theorem. If you want theta A, use the first theorem from A to center. A to center. Then theta A minus theta C equal to area of the BM by EI diagram between A and C. This all I wrote last time. You should write. Clear? Those who want write. Area of the BM by EI diagram between A and C equal to a triangle half into 6 into 240. Half into 6 into 240 by EI. Theta C equal to 0. Why? Center 0. Therefore, you get theta A. Answer. Fast. Theta A answer. Therefore, theta A. 720 by EI. Okay. 720 by EI. Radian. By EI. Radian. Direction see here. Clockwise. Now you write. Due to symmetry, theta B also equal to, you should write 720 by EI radian anti-clockwise. Therefore, for this beam, theta maximum equal to 720 by EI radian, which will be at support. Okay. Cut. Cut means verified. Fully clear? Fully clear or not? I am explaining slowly. Full clear? You got theta A. Full clear? First. Okay. Now, next, I remove everything one by one. Next you require, see, you should see yesterday's question and make fair copy. Next I want Y maximum. Here statement I am not writing, yesterday I wrote. Maximum deflection due to symmetry will be exactly at center. So Y max will be Y at center. Now, to get YC, what you can do is, YC you cannot find. So what you do is, see, draw tangent at C. It is horizontal. This is the point A. It is there. Therefore, this is what? If I see this one, this is displacement of A with respect to tangent at C. So find what is YCA. You write displacement of C. No, YAC. Why not CA? YAC. If you write CA, gone case. Why? If you write CA, you will take moment about C point then. Displacement of point A with respect to tangent at C, YAC, is equal to moment of the area of the BM by EI diagram between A and C about A equal to half into 6 into 240 is the area multiplied by moment about A is CG is here. This full 6 meter. This is 2/3 of 6 divided by EI. Calculate half into 6 into 240 into 2/3 of 6 divided by EI. Calculate. How much? This will give you Y of A with respect to C 2880 by EI. 2880 by EI. But your YAC, this itself is deflection at C. See here, that YAC is deflection at C equal to Y maximum. Okay, then, like yesterday, systematically write. Therefore, maximum deflection equal to 2880 by EI meter at center. Okay, thank you. Over. Now, come to further. Now you have to find slope and deflection at two extra points. See, last time I am doing it. One of the point is P1. Where is it? As per the question, I told you, where I told P1? P1 is at what? 4 meter from left end. P2 is at 2.4 from right end. I forgot the question, I think. Also find slope and deflection at 4 meter from left end, say P1. Okay, come back here. Light line without disturbing. Maybe I will use red color. Why? It is the extra point. It should not disturb the previous value. See, red color. Light line. P1. Okay, P1. Distance is 4 meter. See here. 4 meter. Okay, now that point P1, I want the BM ordinate here. This is the point P1. See, this distance is 4 meter. Extra. Bending moment at P1 equal to 40 into 4 equal to 160. Okay, calculate. Same way later, point P2 is here at 2.4 meter from there. And BM there equal to 40 into 2.4. What is the answer? This is 2.4 meter from here. 2.4 meter from there. Tell me, 40 into 2.4. 42, 80, is it 96? Is it 96? 40 into 2.4, 96. Okay, it is 96 here. Okay, now, see, correctly, one by one. I want slope and deflection at the point P1. It is a new point. See, draw a tangent at P1, theta P1. Now, you should first know slope at support. That already known. So, what you do? If you want theta P1 to get, 1 minute. To get theta P1, apply the first theorem from A to P1. A to P1. Then, as per first theorem, theta A minus theta P1 equal to area of BM by EI diagram between A and P1. A and P1 equal to A and P1. One more triangle. See, red dot triangle. How much? Half into 4 into 160 by EI equal to how much? 320. 320 by EI. Now, theta A is already calculated 720 by EI. So, you get the value of theta P1. How much? Tell me. 720 minus 320. Answer. 720. Take other side. Minus 320. Theta P will go that side. How much? 400 by EI. 400 by EI radians. Direction, you have to see here, clockwise. Okay. Theta P also came. Now, I want what? Deflection at P1. Deflection Y at P1. This is the important. This is where people get confusion. If you want deflection at P1 is here. See, your point P1 is here. P1. If you want deflection at P1, what you do is, you find, see, extend the left, P1 is to left side. Extend the left side tangent here and find displacement of P1 with respect to tangent at A. Find displacement of P1 with respect to tangent at A. That is equal to moment of the area of the BM by EI diagram between P1 and A about P1. Moment between these two, this triangle area, moment about P1. How much? Equal to half into, yesterday fully explained, 4 into 160 is the area. Remember, earlier when I want moment about this point for this triangle, I have taken 2/3. Now I want moment about this point of this triangle. Tell me, is the distance is 1/3 or 2/3? You should be careful about small things. Is the distance is about P1, 1/3 or 2/3? It is 1/3. 1/3 of 4. 4. Divide by EI. Tell what is this answer. tell what is this answer. That answer I want. Half into 4 into 160 into 1/3 of 4. How much? 426.66667. Okay. 426.6667 by EI. Now do one thing. See, you consider this triangle. See here. This triangle. You write tan of theta A equal to this full here. It is y at P1 plus y of P1 with respect to A. This full divided by 4. Okay. But tan theta equal to theta A. Theta A is how much? 720 by EI equal to y of P1 plus this you got 426.6667 by EI divided by 4. Okay. 720 into 4 minus 426.667, you get y of P1. Answer. 720 into 4 minus 426.6667. You get deflection at P1. Answer. 2453.333. It is 2453.333 by EI. Yes. Got the answer. Now, next, lastly, slope and deflection at P2. Shall I do little briefly? Because last time fully told. Shall I do little briefly without writing much? Little briefly without too much of story, because last time fully explained. Okay, now what you do is P2. See, P2 is here. Your P2 is here. Be careful. This is your P2. Okay, now if you want theta P2, come this side. Apply the first theorem from B to P2. B to P2. Then theta B minus theta P2 equal to area of BM by EI diagram between B and P2 equal to half into 2.4 into 96 by EI. Theta B is already calculated as 720 by EI equal. Now 720 minus this answer, you get theta P2. Tell the answer. You calculate this one, then 720, subtract that number, theta P2 will go that side. Answer. 720 minus that number. Answer. 604.8 by EI. Oh, that also came. 604.8 by EI radian. Direction you have to see here anti-clockwise. Okay. Lastly, closing part. Deflection at P2. You cannot find deflection at P2. What you do? You find, see, displacement of P2, that red point P2 with respect to that side, tangent at B equal to moment of the area of the BM by EI diagram between P2 and B, very important, about P2 equal to moment of this area. Half into 2.4 into 96 is the area into its center of gravity is here. From here, 1/3 of 2.4. Tell me this answer in terms of EI. This answer in terms of EI, that is displacement of P2 with respect to tangent at B, that downward portion it is. 6 not hale answer, hosa answer. You are telling old answer. This one. 92.16 by EI. Okay. 92.16 by EI. Okay. Now, lastly, you consider this triangle. Then your tan theta B equal to theta B only, equal to yp2 plus y of P2 with respect to B divided by 2.4. Okay. Therefore, this theta, how much is one? Tan theta B is 720 by EI. Okay. So 720 by EI into 2.4, YP2 is this one. Take other side. 720 by EI into 2.4 minus 92.16 will give you YP2. Answer. Will give you YP2. 720 by 720 into 2.4 minus 92.16 will give you deflection there. How much? 1635.84. Okay. 1635.84 by EI. Everything perfectly tallied. Now, because this question of what simply supported beam with central load is a very powerful question. So many competitive examination, they will ask this one. So what I will do is, I will give an extra question for you, homework with numerical, with the answer. Today only try and get the answer. See, question, homework question. A simply supported beam of span anything, span 10 meter, loaded by a point load of 180 kilonewton at center, 5 meter. Find maximum slope, maximum deflection, and also find slope and deflection at 2 points P1 and P2. P1 is somewhere here. See, P1 is here at 1.2 meter from here, and P2 is somewhere here at 1.8 meter from there. P1 is at 1.2 from here, at 1.2 from A. P2 is at 1.8 meter from B. I will give the answer for you. Correctly work out and get the answer. You never bother what I am doing. Maximum slope 1125 by EI radian. Maximum deflection 3750 by EI at the point P1, theta and Y. Theta. It is 1060.2 by EI. Deflection 1324.08 by EI meter. If not correct tallying, tell me next time. I'll check once again. And P2 answer. Slope 979.2 by EI radians. Deflection 19 deflection 1937.52 by EI. Try correctly and get the answer. Okay. I will now go for new question. I will go for new question now. Why? This is over. Okay. I will rub the full board. Just wait for a few minutes. I should clean the board fully because I should use a wet cloth. Dry cloth means it won't go easily. All I will remove now. Now, next question is a very powerful question. Remember, when you design the steel beams or RCC beam, usually you go for deflection control based on L by D ratio. Correct? Remember, usually people don't calculate deflection for RCC beams. But in steel beams, so many times you get 2-point load symmetrical at either 1/3 span or 1/4 span, etc. Have you seen that one? In steel beams, 2-point load comes. Actually, if you go for gantry girder, usually because of the crane, you get 2-point load. Then you have to go for deflection check. At that time, for 2-point load, you can use formula for finding maximum. See, those point load can be placed anywhere you want because it's a moving point load. Usually place symmetrically and get maximum deflection. Okay, I'll derive a formula for that one now. and go for the answer. Then once the formula is derived, you can use the formula for any value of the distance of the load. Okay. I'll derive the formula. See, I'll tell you one thing. Sometimes, see, span L, load can be at 1/3 span. Load can be at 1/4 span. Load can be 1/5 span. That if you derive the formula for a general position of the load, it is very useful for you. But what I will do now is, I will first do a problem when the position is known. Then, next class, before the class, on the board, I will write the general equation for anywhere placed. Clear? And I will explain to save the time. Today I will take a particular position in terms of L. Next class, before the class, I will write here a general formula for 2-point load. Is it okay? Otherwise, instead of wasting time, full board I will write. Explaining is not required. Today what I am telling, same thing on that day also. See, I will go for question. Question is, see, you should write question. A simply supported beam is of span L. L is the span. It is subjected to 2-point loads. 2-point loads. Usually point load people call W. This time I will call P. P each. This is P. This is also P. P each at middle third span point. A, B, C. A, B. Middle third span point. Tell me what is middle third means. Middle third means what? Divide the beam into how many parts? Tell me. Middle third means divide the beam into how many parts? Divide the beam into how many parts? Middle third means divide the beam into how many parts? Middle third. Then I will give more questions for you. 3 parts. So each part will become L by 3, L by 3, L by 3. Now, after this one, I will give homework for you when it is some other values, briefly with the answer. Okay, start. Question is, find maximum slope and maximum deflection. Okay, then for those only, next, for only those interested, also find slope and deflection under loads. I will briefly explain here. Important is maximum slope and maximum deflection. Anyway, I know the answer. This I know it. It is 23 by 648. If it is the middle third load, somehow I remember PL cube by EI. And slope I remember PL square by, if I remember, 9 I think most probably 9 EI. I don't know. These I don't remember. This is not by hearted. I remember because this question for moment area conjugate beam method academically I had done more than 30-40 times. Therefore, I remember the answer. Okay, let's see. Just the question of remembering. Now, see, A, B. Now I will do one thing now. Don't by heart C is center. I will call this point as C, this point is D, deliberately, so that you should not by heart C as center. Okay, start. Solution. Draw the beam neatly. Neatly draw the beam. See, divide the beam into 3 equal parts. Each load is PP. P and P. P and P. Okay. Reaction you require. Don't waste time for reaction. A, B, this is your C, this is your D. Later you require center. Center will be here. I will call center as E later. This E is center coming later. Okay. Now, right here. Due to symmetry, reaction VA equal to reaction VB equal to total load on beam in downward direction divided by 2 will be each reaction upward. P plus P is 2P by 2 or P. So your reaction VB equal to P VA also equal to P. Okay, now distance I'll write here now. This is L by 3. This also is L by 3. This also is L by 3. Now, you require center later. I will mark later. Draw bending moment diagram. Okay, start. You calculate bending moment at A. Look this side, 0. At B also 0. Look that side, BM at B. Then bending moment at C equal to, look this side, P into L by 3 plus P into L by 3 equal to bending moment at D. So it is, here it is PL by 3. Next question I am putting load at L by 4. Remember, at quarter span, I will tell you 2 loads are at quarter span. See, quarter span means this will become L by 4, it will become L by 4, middle will become L by 2. Quarter, people know what is quarter, not that quarter. Sometimes they will tell, sir, quarter known. Ordinary people on the road know the quarter, not that quarter. Okay, now, this way. Or, remember, if you observe correctly, BM between C and D is constant. Or, by chance, if you draw shear force diagram, just go up by P, no load, come down by P, again no load, come down by P, go up by P. Between the 2 point load, tell me what is shear force? Between the 2 points, tell me what is shear force? Between the 2 point loads, what is the shear force? What is shear force? Between the 2 point load, shear force. No answer. Between the 2 point loads, shear force. This much time to answer. Shear force between the 2 point loads. This much time to answer that shear force. See the shear force diagram. You are not telling any answer. 0. Or if the shear force is 0, then bending moment is constant. Or you can tell one more thing. That portion of the beam where shear force is 0 or BM is constant, that will experience what? Tell me. Anybody got idea? That will experience what? There is a name for that one. A bending with constant bending moment or bending without any shear force. What it is called? A name. If you remember, I don't remember. If you help me, I will remember now. Oh, thank you. Pure bending. Okay, thank you. Okay, now, over. Now, draw elastic curve. See, now 1 minute now. For some reason, see, this is L by 3. I will write once again. L by 3. Now, you know that deflection is maximum at center. Therefore, you also require later what is this distance. Anybody can tell this distance? Up to C, this is the point A, this is B, this is C, this is D. At E, bending moment is same. How much it is? Total is L by, see, this is L by 3, half. How much? It is L by 6. Now, clear? It is L by 6. Okay, start. Now, draw elastic curve. Today, I will draw elastic curve with the red color, just for a change. Elastic curve, red color. As smooth as possible. Okay. This is the point A. This is the point B. Your point E will come here. Point E will come here. And at the point E, now E is the center. Be careful. Not C. This is E. This is tangent at E. This also is tangent at E. Don't buy at ABC. Theta E equal to 0. And this is your what? This is your displacement of A with respect to tangent at E. And if I draw one tangent here, this is your theta A. Due to symmetry, this is theta B. Same answer. Then start first. Theta maximum. You know, for simply support beam, theta max equal to either theta A or theta B, but both are same here numerically. Therefore, find only one value, theta A. To get theta A, apply the first theorem from A to that point where slope is 0, or to find slope at support by moment area method. For simply support with symmetry, apply the first theorem from support to, don't call C, tell where, don't call C, from support up to where? Apply the first theorem from support to, which point? Support to. Do not by heart C, A, B, C, D. Apply the first theorem from support to. What you have done last time, 2 questions. Apply the first theorem from support to where? This much time. We already done the question just now. Apply the first theorem from support to where slope is 0, that is center. A to center. Here center is E. So your theta A minus theta E equal to, you should write area of the BM by EI diagram between A and E. You should write equal to, see, between A and E, one triangle and one rectangle. Triangle area, half into L by 3 into PL by 3. PL by 3 is one rectangle area plus one rectangle area L by 6 into PL by 3. That answer divided by EI. But you know that theta E equal to 0. Therefore, you get theta A. Calculate. See, P into L, L square. P into L, L square. Both are PL square. So, you will get PL square by EI into number will come. I told 1 by 9. What is the number? Tell me. What is the number? Number. I think 1 by 9 I got. If I remember correctly, it is 1 by 9. Calculate. Half into 3 into 3 plus 1 by 6 into 3. Answer. You should give it answer fast. 1 by 9. Correct. What I told. It is PL square by 9 EI. That much clockwise. Then write. Due to symmetry, slope at B also equal to same PL square by 9 EI anti-clockwise. Therefore, your theta max equal to PL square by 9 EI where? At support. At supports. Tell me. Fully clear? Maximum slope? Maximum slope. Fully clear? Is maximum slope full clear? 2PL square. Clear. Okay. Now, go for maximum deflection. Okay. I don't know. Looks like correct. Now I want Y maximum. Right. Due to symmetry, Y max will be at center. Will be at center. That is E, not C. So your Y max equal to Y at E. So to get YE, I told you find displacement of left support A with respect to E. See, this is your YC, YE. If you want YE, find what? Displacement of A with respect to tangent at E equal to moment of the area of the BM by EI diagram between A and E. Very important. About, since you are finding displacement of A with respect tangent at E, A is the first point, about A equal to moment of these two, one triangle and rectangle, about A. Half into L by 3 into PL by 3 is the area into moment of that area about this point is 2/3 of L by 3, 2/3 of L by 3 plus rectangle area. L by 6 into PL by 3 is the next area into moment of that area about A means L by 3 outside. L by 3 outside plus half of L by 6 divided by EI. Calculate. See, PL into L into L, PL cube. PL into L into L, PL cube. So PL cube will come outside, divided by EI will come number. Tell the answer. 1 by 2 into 1 by 3 into 1 by 3 into 2 by 3 of 1 by 3 plus 1 by 6 into 1 by 3 into bracket 1 by 3 plus 1 by 12. Answer. Operate calculator, tell the answer. Operate your calculator and tell the answer. I wrote 23 by 648. I remember it's correct most probably. Other one I don't remember. For middle third span, somehow I remember 23 by 648. If you confirm it, I write the answer. If wrong, my memory problem. It is not structural problem. By hearting I am weak. Little fast, wasting time. Thank you. 23 by 648. 23 by 648 over. This is, that itself is equal to what? That YAE, whatever you got, equal to YE, equal to Y maximum. Therefore, presentation, what? Maximum deflection equal to 23 by 648 W abhyasa, sorry, PL cube by EI is the answer. 23 by 648 PL cube by EI. Now, I will give a hint for you. See, 1 minute now, check the answer. Check the answer. Make a note. Next class, I will derive a formula for you for a simply supported beam with the 2 point loads. I will call W, not P. At that time, I will call WW. At any random distance A from here and A from here. Span is L. See, I will tell you bookwork so that, see now, next question will be when the loads are not L by 3, loads are L by 4 or L by 5, you can do it now. See, if they give L by 4, this is L by 2, half L by 4. If they give L by 5, find distances. Again, same procedure. But if you know this formula, you can use it to any loading. The answer, I know it. Tell why? Because I use it in steel. It is Y max for this formula is WL, it is 1 minute near. The formula is W into A divided by 24 EI into bracket 3L square minus 4A square is the formula. It is not by hearted because I used it so many times. Okay, now check the answer. Now this formula can be used for 2 point load symmetrically placed anywhere on the beam. Today you put, tell me, in the formula you substitute A equal to what? Tell me now. Now today's question, in the formula substitute A equal to how much? Substitute A equal to how much? A equal to. Substitute A equal to. In the formula here, A equal to half of L by 3. Ayyo, see the question here. Half of L by 3. What is? See here, A equal to L by 3. Substitute A equal to L by 3. Then take your calculator. 3 minus 4 into 1 by 9. 3 minus 4 into A is L square comes outside. I touched the volume button. 3 minus 4 into 1 by 9. Answer into 1 by 3 divided by 24. You have to get 23 by 648. Getting? Tell the answer. Check the calculation. Put that A equal to L by 3. When it is L by 3, L square comes outside. See that L square into L cube. 3 minus 4 into 1 by 9. Whatever you get into 1 by 3. answer divided by 24, you have to get 23 by 648. Are you getting? Yes, getting. Okay. Now, over question. Now see, I will give homework for you. This I will tell you next time. Next question will be simply supported beam, span L, two loads of WW, not 1/3 span at L by 4 from here and L by 4 from here. That is quarter span. Clear? Okay. Now, same way, see, this is L by 4, this also becomes what? L by 2 minus half, L by 4 comes. Solve this one, answer. I will give you theta max and Y maximum. Theta max is WL square by EI into number, Y maximum is WL cube by EI into number. Number is not a big issue. Calculate this off. Ayo. 3 by 32 is the number for maximum slope. Maximum deflection. (11 by 384). Okay. Try these two questions. Clear? Try these two questions. Okay, done. Try these two questions and also do one thing, because see, we can't waste time in the class unnecessarily. Also, you take a numerical problem and solve. See, I'll tell you numerical problem. See, simply supported beam of span say 12 meter, subjected to 2-point load, neither L by 3 nor L by 4, at distances of 5 meter from ends. 5 meter from ends. I will do one thing now. 16 meter span, 5 meter. Loads are 36 kilonewton and 36 kilonewton. A, B, C, D. Question is, find theta max and Y max. I will give the answer. Can you do it? See, when you do moment area method, this is 5, this is 8 meter, this will become 3 meter. See, can you solve this one? Tell me. You can solve means I will give answer. You can solve means I will give the answer. Okay. Answer is, calculator. I am using mobile for calculator. 36 into 5. Even I am also doing my moment area method only. Half into 5 into 180 plus 3 into 180. 990 by EI. Deflection is half into 5 into 180 into 2 by 3 of 5 plus 3 into 180 into bracket 5 plus 1.5. 5010. See, that's all it takes. That's all it takes to solve. If you imagine correctly, see how I did it. That's the question. Okay, now this also you solve. Okay, now for this question, see, for the present class question, only for those who are serious, you find slope at C and deflection at C. Remember, whatever theta C will be equal to theta D. But one thing, if theta C is clockwise, theta D will be anti-clockwise. Whatever deflection at C down will be equal to deflection at D. See, what you do is, I will tell you now, mark the point here, draw tangent here, apply the first theorem from here to here. You get the answer. Theta C will come PL square by 18 EI. And to find deflection, find what? Deflection of this point with respect to tangent at A. Remember, you find this one, then this is required YC. Then apply trigonometry and get YC. So those who are serious, try it. That is, answer is 1/6 into 1 by 3 into 1 by 12 minus 23 by 648. 5 by 162. That's all. See, 5 by 162 PL cube by EI. Okay. Those who are serious, others not required. I do not want to unnecessarily waste the time for unwanted things all. Clear? Okay. Now, one important question is there. I will solve now. That is same question. See, those who are writing competitive examination, this is very important. See, this formula you can use when your beam has got 2-point loads, and remember EI should be same. But so many competitive examinations, see, even for PWD also they ask the question. PWD, because this question is very, very simple question. People expect you to know that much. See, I will give the question. A simply supported beam has a span of numerical value, has a span of say 10 meter. Now, it is subjected to 2-point loads of 60 kilonewtons each. 60 kilonewtons each at 3 meter from either ends. Okay. Okay. Now, if that's all given, see, A, B, C, D. If that's all given, can you solve now? Tell me. If that's all given, can you solve? If that's all given, can you solve? Yes or no? That's all given. Simply support beam of span 10 meter loaded by 2-point loads of 60 kilonewtons at 3 meter from ends. Write a note. Write a note there. If that's all given, we can easily solve. Answer will be theta max and y max. I will give you homework. 18. Half into 3 into 180 plus 2 into 180. Theta max will be 630 by EI and y max will be half into 3 into 180 into 2 plus 2 into 180 into 3 plus 1, 4. Okay. 1980 by EI. Don't worry about speed because I got better speed over. Right? If that's all given. But note, not that's all, further something given. Now see, question. In the question given, a simply support beam of span 10 meter loaded by 2-point loads of 60 kilonewton at 3 meter from ends. Now, further, if that's all given, answer. But further given, flexural rigidity. Flexural rigidity. Usually what they will do is, such question, they will give by words, they will give sketch only. Tell me, what is flexural rigidity? Tell me, what is flexural rigidity? What is flexural rigidity means? First. What is the meaning of flexural rigidity? First. EI. They told in the question, flexural rigidity of the beam cross section. So many people tell of the beam. Nonsense. 90% people tell for the beam. It is not for the beam. It is for the beam cross section. Okay, done. For the beam cross section, between the load points, see, between the load points is 3EI and for remaining portion it is 2EI. Oh, that means your beam is non-prismatic like this. Clear? This is 2EI. This also is 2EI. This is 3EI. It is non-prismatic. Tell me, clear or not? Question. It is non-prismatic. Clear? Pure exam-oriented question. Clear or not? They told little out of scale. This is 3 meter only out of scale. Clear? Okay. Now, solution. Find maximum slope and maximum deflection. Theta max and y max. Okay, start. First, there is a reaction VA here, reaction VB here. Reaction will not change. VA equal to VB equal to total load on beam divided by 2. 60 plus 60 is how much? 120 by 2 is once again 60 kilonewton. Okay. Draw the beam neatly. Then I'll give one homework for you. Okay, usually they don't give 2, 2 and 3. Usual practice is they give ends EI, middle to EI. Homework I'll give you. See, start. First, this way it will come for 3 meter. Then central 4 meter, it will go this way. Again back to 3 meter. See. Now, this point load is 60 kilonewton. This point load also is 60 kilonewton. Reaction I told 60 kilonewton. I won't waste time. VA will be writing all. This also 60 kilonewton. This distance is 3 meter. The central length is 4 meter. This is how much? This is 3 meter. Draw the bending moment diagram. BM0 here, BM0 here, A, B, C, D. So this is 2EI, this is 3EI, this is 2EI. Now, BM0, BM, here, BM, 60 into 3, 180. That much you should do, 180. Same here also, 180. 180, back to 0 here, back to 0. This is the bending moment diagram. Now, all values are in kilonewton meter. Some people draw BM by EI diagram, moment area method not required. But conjugate beam method, you have to draw BM by EI diagram next time. Okay, start. Now remember now, anything you do for this area, tell me, note, anything you do for this area, warning, tell me, divide by how much? Anything for this area if you do, divide by what? Anything you do, calculate for that area, warning, divide by what? Any calculation, see, when you draw BM by EI, if you write anything for this portion, then you should divide by, warning, how much? 2EI, remember, 2EI. And anything you do for this one, tell me, you should divide by how much? Divide by 3EI. Here also, anything on this area, divide by 2EI, remember. Okay, now, little later, center required, I will call E as center. So now, this is 3 meter. I want only up to center here. This is center E. So this is further 2 meter. Draw elastic curve. Over question. See, I use red color for elastic curve. This way. This is your deflection at E. And that is Y maximum. This is the point A. That side is not required. This is tangent at A, theta A. Tangent at A. Now, this is the tangent at E. It will come this way. Tangent at E. Theta E equal to 0. Then, first, I want to get theta maximum. Theta maximum. As usual, either theta A or theta B, both are equal. Find theta A. Use the first theorem from A to center. A to center. Theta A minus theta E equal to area of the, I write now, area of BM by EI diagram between A and E. Theta E equal to 0. So theta A equal to area half into 3 into 180, half into 3 into 180. Remember that area divided by 2EI plus one more area 2 into 180, 2 into 180, that area divided by 3EI. Tell the answer fast. Answer. First area divided by 2EI, second area divided by 3EI. Answer. Little fast. Little fast if you give, I can, you see, in now onwards, there are so many people are there, but nobody is giving, only few known people are giving answer. See, now, yesterday and earlier days, you don't know. Suddenly I saw live strength crossing 300, 400. Today also around more than 200. But when so many people are there, why don't you participate? If you participate, you get confidence, time is saved. I will be happy that so many are giving answer. Don't worry, if I write, my name will come. I will never remember your names all. 255 by EI. 255 by EI. Over. Therefore, presentation, theta max equal to 255 by EI radian clockwise at supports. Okay. Now, next I want Y maximum. Maximum deflection due to symmetry equal to Y at center. That is YE. Start. To get YE, find what? Y of, see here, Y of A with respect to E. Y of A with respect to E. Start. Y of A with respect to E equal to moment of area of BM by EI diagram between what? A and E. About, be careful, about A. Okay, start. One area, half into 3 into 180 is the area. Its moment about A, CG is here, 2/3 of 3 into 2/3 of 3. That area, answer, divided by 2EI, be careful. Then plus one more area, 2 into 180. 2 into 180 is one more area. Its moment about A is 3 meter plus another half of 2. Half of 2. That one divided by 3EI. Tell the answer fast. Answer fast. Over. See, over. That's all. Answer. Little high speed. I will give homework for you. Today only work out. See, if such question comes for PGCET or GATE, PGCET came twice. GATE or any PW, etc., RW, EWD, etc. Within no time you get the answer. See, if you know the principle, rough bending moment diagram, you don't have to think. If you want deflection, take moment of these two area about this point. If you want slope, only area of these two. If EI is changing, each part divide by respective EI. 750 by EI. Over. Don't give wrong answer. 750 by EI. EI. That is YAE. That itself is YE equal to Y maximum. Write the answer. Therefore, maximum deflection equal to 750 by EI meter down at center. Fully clear? I will wind up now by giving a simple question homework for you. Work out today only, get the answer. Full clear? Work out right now and get the answer. See, now you can make out what speed you can do. See, you see what speed I am giving answer. How? I never come to the class by hearting something. I never use any formula. See, now, next question, pure homework. Because usually exam what they do is, see, I will give a sketch for you. This is a beam. This is a beam. This is EI. This is EI. This is 2EI. 1 point load here, 1 point load here. See anything? 32 kilonewton, 32 kilonewton. Distance from here to here and here to here given. Span given. Span is 10 meter. This is 3 meter. Not 3 meter better. Already 3 meter there. Span is 8 meter. This is 2.4 meter. This is also 2.4 meter. Find theta max and Y max. 4.8 minus 10 is 5. 10 minus 4.8 so much divided by 2 is 2.6 meter. Ayo, calculate not on. Again calculate not on. 10 minus 4.8 divided by 2 is 2.6. This is 2.4. That is 2.6. And bending moment is 32 into 2.4 is 76.8. Answer is half into 2.4 into 76.8 plus 2.6 into 76.8 divided by 2. Theta 192 by EI maximum deflection. Half into 2.4 into 76.8 into 2 by 3 of 2.4 plus that is 2.6 into 76.8 into bracket 2.4 plus 2.6 divided by 2, answer divided by 2 equal to 516.864 by EI. I also did by moment area method only. See, if it is objective question, you can see they will ask only one of them. It took me how much? Around 20 seconds. That's all. Clear? Can you try and get the answer now? Fast. Can you try this and get correct answer? Span is 8 meter. Oh, I have taken 10 minutes span. Okay. Oh, earlier. Okay, change the question. Span is 10 meter. Then if it is 8 meter, no problem. I should take this as 1.6 meter, correct? If it is 8 meter, I have changed the answer. Okay, no problem. I took this 2.4 and 2.6. So span is 10 meter. So what? But exam you can't do that way. See, exam, if I write exam, I'll be careful. So I first told 10, some 3, not 10. Then I changed to this one. I forgot it. Okay, span is 10 meter. If you want words question, beam of span 10 meter, EI for the portion between the load is twice that of remaining portion. Find theta max and Y max. Clear? Okay, I corrected it now. Question fully clear? Tell me fast. Can you solve now? Then next I will go for different type of problems. Okay, thank you. Already 8:58. See, you got another 2-3 days rest now, because next Tuesday is the class. By that time, study the full moment of inertia, because next class I will tell you moment of simply supported beam, if it is unsymmetrical load, what to do. Remember, for competitive examination, formula is required. But for any important exam like engineering service or academic questions, solution required. So I will complete that question when the load is unsymmetrical. Then slope at center is not 0. Nothing to worry. Very easily you can solve. I will make it as simple as possible. Okay, thank you. I will make as simple as possible.